let's look at a bit more practical example of matrix multiplication and trying to understand like the different kind of spaces, matrix spaces that you can kind of go in and out of. Because I think it might not have been like fully clear just from like the talking in the previous video where I was just going through them. So let's look at a bit more of a practical example here. So what I've got here is I've got two different objects. I've got a jet and I've got like a wasp. Now they're moving in different kind of directions and orientations in the world here. And really what I want to do here is I want to make this wasp have basically like the same kind of animation but follow along with the plane. So it would basically be as if I kind of parented it underneath here and it would be doing this, right? So you would basically have kind of this same kind of movement that we have, but within this kind of, within the space of the fighter jet, right? So if I just undo that, make sure that I unparent, and I still have all of this happening. So what I've got is I've just got a new object called Wasp Jet Fighter. So that's the one that we will put in here, and we'll use the matrices of the Wasp and the Jet Fighter to create a new final matrix for this Wasp to kind of move in. So what I've got here in the node editor, I've got the Jet Fighter, I've got the Wasp World, which basically has the main animation here. And what we'll be doing is, because we don't really have anything above here, I'll just use the matrix right now. But if you had like groups above, you would want to use the world matrix, but I'm just going to use the matrix now because that has all of the values that we need. So first off, let's just try and say, we got the jet fighter movement and then we got the wasp movement. Can we just do jet fighter multiplied by the wasp world, and that should do it? So let's try that. Let's get that matrix, get that in here. I'll take the sum, I'll add it into the wasp, and I'll just get rid of these kind of offsets that we had here as well. And that kind of looks like it's working, except for, is it? It looks a bit weird. So really, if I move this up and down now, it should be moving away from the plane, and it's not really doing that. It's actually, you can see it's moving within the plane space, and really this wasp, there's no animation on the X, it's just going up and down and forward. So really, that's a bit weird that we're seeing it kind of moving in and out of that space there. So let's try and do this other way here. So let's try and do the wasp first, and then do the jet fighter afterwards, and see what we got now. Okay, yeah, that looks much more better. Now we can actually see that it's going, as this kind of is rotating, the wasp is sticking with it. And if I move this up and down, we can see that it's moving up and down in the jet fighter space. So what's happening here? Well, the really important thing to think about when you're multiplying matrices together is that basically each matrix in the kind of mathematical sense here, like how it's being multiplied together, is just kind of treated as it's like a full world thing. So what's happened when we, let me just go this back here, when we do the jet fighter first and we do the wasp afterwards, is that first we get the jet fighter movement. And then afterwards, we have this new matrix that will then offset the jet fighter movement, but in world space. So right now, if I move this backwards and forwards, we can see that this, if I rotate it, it's just going to be stuck in space there. Because really what's happened is that first we get all of the kind of movement from the jet fighter, and then we offset from that. And that's basically the offsets that we're getting here. And that offset, you can see now, is pretty much 1-to-1, because it's just added at the very end, which just means that it takes everything that we've done before, which is basically the jet fighter, and then we offset that in world space. So it would be exactly the same as if we set this into like world and just did this and applied the same values. So that's why we first have to get our wasp movement. We have to figure out all of the values that we have for the wasp, and then we take those values and we offset them by the jet fighter movement. So basically we want to have all of the wasp movement happening at the origin, and then we want to take all of those values and basically, almost like as we looked at here before, kind of parent them underneath that object here. So if I take the jet fighter in here now, we can actually see now that when I parented this wasp in here, that's giving us the, if I just go into object, that's giving us the exact same kind of movement as we have for the wasp jet fighter. That's just like fully in world space. So that's pretty much like the key thing that's happening here. I'll unparent this again now, and we'll just kind of play that back. So I would really just recommend that anytime that you're thinking about like matrix multiplication, if you're having difficulties, like kind of struggling with understanding how things go in and out and which order, think about it as like kind of parenting things in here as well. Because basically when you kind of multiply when you parent things in Maya, that's basically like a multiplication here. So when I take this wasp and I put it into this jet fighter here, it's doing this exact multiplication here to figure out where this should be in world space. Is that it actually takes the matrix of the wasp, it'll multiply it by the jet fighter matrix, and that'll actually be now the new world matrix for this wasp here. So I'll just get that back in here. Okay, so hopefully that is a bit clear. It's a bit difficult with this, and I always kind of struggle to come up with like a good analogy here, but hopefully that kind of shows it a bit nicer. Now let's just kind of continue onwards here a bit, and let's say that, what if I got that scale, don't I? Yeah, sorry. Let's say that what we started out with was actually having the wasp in the kind of jet fighter space, but we wanted to get rid of the kind of movement from the jet fighter so that we just get the wasp to be at the origin, so that we just want that the movement of the wasp in this local space, we're going to put that at the origin. How could we do that? Well, I'm just going to duplicate this out again, and I'm going to call this local. So what we can do now is, if we go in here, and I will add these in, and I'll take this wasp local here as well, make sure that I get that one here. So what we can do now is we can do another multimatrix here, and sorry, if I just open up this one, there we go. So what we want to do now is we basically want to take the world movement, the world matrix of this wasp, and we want to take away the movement of the jet fighter. So if I go here now, and let's say we'll take the world matrix here, so if I do that, and then we take the jet fighter, and I get the just a world inverse matrix of that. Oh, let me see here. And if I now take this here, we should now see the exact same movement that we had previously. So we can see that's now going up and down. And if we unhide this, these should now be moving exactly the same, because we've basically taken that kind of the information that we added by the jet fighter, that matrix, we've removed that by taking the inverse of that. So remember that this wasp jet fighter, the world matrix of this now, is basically the wasp world multiplied by the jet fighter matrix. So both of those matrices, it would be the same if it was like the world of this and the world of this. That basically creates this jet fighter. So if we wanted to if we wanted to retrieve this again, we basically have to get rid of this. So this is basically how you would put something into like a local space if you wanted to get out like the local movement of something, or if you want to remove any kind of movement as well from something that was moving in world space. So again, we get the wasp. So that's the one that we figured out here, the jet fighter one. Take the world matrix of that, and again, the world matrix is the wasp world local matrix multiplied by the local matrix of the jet fighter, and we basically remove the world inverse, or with this, because we can just do the inverse of the jet fighter here, because that is the same here, because we don't really have anything above the jet fighter. Now, if I group this and I move this over here, you can now see that the wasp isn't following anymore. So that's where we would have to use the world matrix for this, for the jet fighter. So if I say world matrix and I add that in, you can now see that we get that offset back in there, and it's still working. And at this point, we would then have to make sure that we actually use the jet fighter world inverse matrix to get that back to the origin here. So again, that's why it's like each of these times when you group something like this in Maya transforms, it's actually just doing a matrix calculation on each of them. So it's taking this one, the local matrix of this, and multiplying it by the local matrix of the parent, and then so on and so on. It keeps on going. Okay, cool. So that was a bit more on like different kind of matrix spaces. I hope that cleared up some things. It might have not, or it might have. All this stuff is very difficult, so you just need to get into like understand it in your own kind of way, and find a way that makes sense for you to kind of get these things. But that's how I would recommend thinking about it, is that you have like each matrix going into another is like parenting them together, because that's basically what the math behind it is.